Quickly going to review with you today the function families or graphing questions that are going to be on your semester exam. The first thing we want to do is talk about the function family. So what kind of function family is happening here? This is your square root function or your radicals. Specifically, this one's the square root, because your parent function is just going to be the square root of x. Now, we don't necessarily know what this function looks like, so what I want you to do is to pause real quick and just type that into Desmos. Now that you've put it in Desmos, did you see that my function is going to start at 3, 1? It's going to go through 4, 0, and then kind of continue down like this. This is going to help me talk about the transformation that is happening in this function. How did I transform it? The first thing I did is I reflected it. This minus sign out front means that it has been reflected, because a normal square root function starts at 0, 0 and goes this direction. So it's been reflected. It's been shifted to the right 3 units, and then up 1 unit, because it normally starts at 0, 0, but because I've subtracted 3 and added 1, I've changed where it's going to start. So then let's talk about domain. Domain is all of your possible x values. They kind of start and stop right here at 3. So x has to be greater than or equal to 3. Another way you would see this written is bracket 3 to infinity. Or range is all of your possible y values. And I don't have all of my y values because they start right here at 1, and then they include everything below. So y has to be less than or equal to 1. Another way to write that would be negative infinity to number 1 with a bracket. The reason we write negative infinity first is because negative infinity is smaller than the number 1. Another word for zeros would be solutions. Sometimes you'll see X-Intercepts. They're all meaning the same thing. So where does this graph cross my x-axis? It crosses it at 4, 0, which as a 0 or a solution would just be x equals 4. End behavior for this function, you're really only going to get asked one direction. What is happening as x increases? So as x is approaching positive infinity, what is happening to y? Well, it's getting more and more negative. So it approaches negative infinity. We can't go the other direction because x is not approaching negative infinity. We do not have all real numbers in my domain here. There are no asymptotes in a square root or radical function, so we do not have to worry about those. Inverse, however, very popular question. Most of the time you're going to get a question that's multiple choice, and it will say select which of the following is the inverse, yada yada. But to find the inverse, just for a refresher, we're going to switch x and y. So our function was y equals negative square root x minus 3. So we're going to say x equals negative square root y minus 3 plus 1. And then our second step is to solve for y. So to do that, we're going to subtract 1 from both sides. Then we're going to divide each side by a negative 1. So my x becomes negative, my 1 becomes positive. We're going to take the square of both sides and then add 3. So my final inverse is going to be negative x plus 1 squared plus 3. There's my inverse. Now, the second function that I want to talk about is this rational function. So the function family that we're talking about here is the rational. Sounds like a fraction. This is your rational function family. So we don't have a picture, so what I want you to do is pause real quick and type this into Desmos. You type this into Desmos, you're going to get a function that looks kind of like this. What you're going to notice is that there's some clear gaps right here. We've taken our x and our y axis and we've shifted it up and over. And so this is going to help us figure out how we've shifted our function. We've shifted it to the right 3 and up 1. You aren't going to get asked a transformation question for rational functions. You're most likely going to get it asked for radicals or logs or exponentials, which are coming up next. But just for the answer key purposes, that is what we're going to get. Let's talk domain and range. We don't have all of our possible x values because we've got this hole that happens right here at x equals 3. So a lot of times your question is going to say which value is not in the domain. Well, 3 is not in my domain. You might also see your domain split up like this with a union in the middle. Same range. You're not going to see a what is the range question. You're going to be asked what value is not in the range. Well, 1 is not in the range because we have this asymptote here. And so if we were going to write out the range, we would again have a union to join those two together. You're not going to get asked a zeros question, but there is an x-intercept here, and so we would just fill in what that is here using Desmos. Again, the other question that you are definitely not going to receive is end behavior. You do not need to know that. You do not need to know end behavior for a rational function, mainly because as x is approaching positive infinity, we've got something that's decreasing here and something that's kind of doing this weird approaching the number 1 thing here. And so you can't be approaching negative infinity on one side and 1 on the other. So we're not going to be asked about end behavior. Asymptotes, however, can guarantee you're going to see a question about asymptotes. Do we have a vertical asymptote? Yes, it happens here at x equals 3. Do we have a vertical asymptote at x equals 3? Do we have a horizontal asymptote? Yes, we do. It's at y equals 1. And I can guarantee you will not see anything about inverses for rational functions. We just simply don't know how to do that with our level of math, and we're not going to attempt it. The last two function families we want to talk about are our exponential function families and our logarithmic function families. Starting with our exponential, take 2 seconds and just graph this in your calculator. So what do you notice? Look something like this. My domain for this function is rather easy. It's all real numbers. I can plug in any number I want and I'm going to get something back. Yes, even the number 5. It's just going to be way up off of my graph. I could even type in 10 and I'd get something all the way up here. It eventually is going to give me any number I want in my domain. However, my range is a little more restricted. Did you notice that my range kind of cuts off right here at this asymptote? Y equals 4. In fact, I'm seeing that right here in my transformation as I've been moved up 4. The fact that I've gone right 1 has nothing to do with it. So the fact that I've gone to the right 1 and up 4 has nothing to do with my asymptote down here. It's just to do with my horizontal asymptote, the fact that I've gone up 4, which is going to affect my range because my range has to be greater than the number 4. Nothing can be less than that. There are no zeros for this particular exponential function. Sometimes there will be. Just be on the lookout for where it crosses your x-axis. End behavior is a super big one for exponential and logarithmic functions, so please make sure you know end behavior. You're going to get asked one of two things. As x is approaching negative infinity, what is y approaching? Take a second and look at the left side of our graph. As my x is getting bigger and bigger and bigger, what is my graph approaching? Well, it's approaching my asymptote. It can't be going below my asymptote towards negative infinity. It's just getting super, super, super duper close to my asymptote. And my asymptote is 4. On the other side of my graph, as x is approaching infinity, I see that my graph is diverging. It's going straight up to positive infinity. So y would be approaching positive infinity. Now for my inverse, we're going to follow the same 2 steps. The first step is to switch our x and our y. So we're going to have x equals 2 to the y minus 1 plus 4. We'll subtract 4 from both sides. And then we'll want to get rid of this base 2. To get rid of a base 2, we have to take the log of the same base, 2, of both sides. To do that, our log and our 2 are going to cancel out, and we're left with just y minus 1 on the right-hand side. But now we have a log base 2 x minus 4. So my final answer is log base 2 of x minus 4 plus 1. Take a second and just notice, instead of a base 2, I have a log 2. Instead of a plus 4, I have a minus 4. Instead of a minus 1, I have a plus 1. Everything about this function is the inverse or opposite of my original. That's how I know I've reached the correct inverse. Let's talk logarithmic functions now. Take a second, graph this in Desmos. Now that you've graphed this in Desmos, let's take a second and talk about what it means. Did you notice that you have a drop-off? That no matter how much you try, you'll never get close enough to x equals 3? That's because you've been shifted to the right 3 and up 2. Now the up 2 has nothing to do with my shift here, but it has everything to do with my vertical asymptote, x equals 3. It also is going to affect my domain. My domain is not all real numbers because there's nothing on this side of my graph. Instead, my domain is going to be x has to be bigger than 3, or 3 to infinity. My range, however, is going to be all real numbers. I can pick any number I want, and I'm going to get back a x value. Now, it may not feel like you're going to get something for 10, right? Will y ever equal 10? Yeah, it's going to be in like the 100 millions. But you would get back a value for the number 10. You do have a 0 here. Your 0 is at 3.01. And again, end behavior, very, 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 very important for a logarithmic function. You're going to be asked, as x approaches your asymptote, 3. So as x is approaching my asymptote, am I going up or am I going down? And the answer here is I'm coming down, so my y is approaching negative infinity. Then, as my x is going to the right, as it is increasing, going towards positive infinity, what is my y doing? Well, it is also increasing, so it is going towards positive infinity. Lastly, we need to talk about inverse. Just like with exponential, we're going to find, we need to switch our x and our y values. Y minus 3 plus 2. We'll subtract 2 from both sides. And now we're left with getting rid of a log. Now to get rid of a log, we need to raise that log to the same thing as the base. Now the base of this log is 10 because it's an implied base. So we're going to put log base 10 of y minus 3 into my exponent. The same thing on the other side. We're going to raise each side into the exponent with our base being 10. So now I have 10 to the x minus 2 equals, my log base 10 and base of 10 cancel out, y minus 3. So my final answer for my inverse is 10 to the x minus 2 plus 3.